Hi, everybody. Today we're going to be going over section 3 from chapter 1 on linear functions. And we're going to start off here with an example. So let's read the example. As you hop into a taxi cab in Allentown, the meter will immediately read $3.30. This is the drop charge made when the taxi meter is activated. After that initial fee, the taxi meter will add $2.40. So let's highlight these numbers. So we start with $3.30, which is the drop fee, the drop charge. And then after we pay that initial amount, the taxi meter will add $2.40 for each mile. Okay. So in this scenario, the total taxi fare depends upon the number of miles ridden in the taxi. And we want to ask ourselves whether we can somehow model this scenario with a function. And I'm certain that we can. Let's figure out how. Now, remember here it says using descriptive variables. We haven't really talked that much about descriptive variables. What we mean by descriptive variables is instead of using X and Y's, which don't really say much of anything to me, what I'm going to do here for this problem is I'm going to use M for miles and C for cost. And we're going to end up with this function, the cost in terms of miles. So let's see how we would begin. The first thing we're going to do is we're going to say C, the cost, as a function of M, which is the miles, is going to equal, well, if I get into a taxi cab and he turns on the meter, the minute he turns on the meter, I'm going to have to pay him $3.30. That's what this says. If I get right out of the cab, I still owe $3.30. I haven't gone anywhere, but that is the cost of getting into a taxi cab and having the taxi driver turn on the meter. So no matter what, I have to pay that $3.30. Okay. Then for every mile that I have him take me somewhere, I have to pay $2.40. So if I went 1 mile, it would be $3.30 plus $2.40. If I went 2 miles, then I'm going to have to pay another $2.40. And for every mile that I go, I pay $2.40. So instead of adding $2.40 up every single time I go another mile, what I'm going to do is multiply the $2.40 times the number of miles. And I now have an equation. I have the cost is equal to $3.30 plus $2.40 times the number of miles I'm going to go. Okay. And if we were to graph that, let me make this a little bit bigger, I think. Yeah, that looks good. So let's start. When M, and here it says, notice here it says X, but we're not using X. We're using M. And here it says Y. We're not using Y. We're using C of M. Okay? So we have our horizontal axis, we have our vertical axis, and now we know what they are. And so when I go 0 miles, I plug in 0 into my M. And obviously 0 times 240 is 0. So I'm going to pay $3.30. It's going to be a little hard to be precise, but let's say this is my first point. When I go 1 mile, I'm going to take $3.30 and I'm going to add $2.40, which is going to give me $5.70. So 1 mile, here's 5, and let's say right here is 70 cents. Okay? And then, excuse me. Actually, let's make a little table over here. So miles and the cost. So if I go 0 miles, it's going to cost me $3.30. If I go 1 mile, it's going to cost me $5.70. If I go 2 miles, now I'm going to add 2 times 40 is 480 plus 330 is going to be $8.10. So let's see where that comes up. 2 miles, here's 8, and let's make this the 10 cents. And if I got it anywhere close, I should be able to make a straight line through those points. Let's see if I can make it happen. Not too bad. So I start here at 0 and I keep going, and this will go on really forever, right? It's a little thicker. Okay. So this is approximately the graph. And we can see why we would call this a linear function, because notice it's graphing to a line. And we really wouldn't have any negative miles. We're not going negative miles, so we wouldn't have anything to the left of this vertical axis. Okay, now let's talk about what this all means. We have this equation, and we have, if we were to say y is equal to mx plus b, because that is the equation of a line in slope-intercept form, I can replace this by saying c of m is equal to, and I'm just going to switch the order because my m is really the same as my x here. So I have $2.40 times m plus b is my intercept, and here b is my initial charge, $3.30. So we can see that if I wanted to find the slope of this line, it would be 2.4. Excuse me. It would be 2.4. The slope is also known as our rate of change. So our slope here is equal to 2.4. It's $2.40, but we can call it 2.4. We can say that's the same as my rate of change. And you can see that there's a constant rate of change. 2.4 is a constant. Okay, and that's what helps make this line go in a certain direction. So we'll talk about linear functions. A linear function is a function whose graph produces a line. We just saw that, and we also saw that that is our linear function. and can always be written in one of these two forms. So we did actually start out saying that C of M is equal to $3.30 plus $2.40 times M. So we started off in the first form, and then we put it into the form that we're much more familiar with. C of M is equal to 2.4 times M plus 3.30. Okay, actually, let me put a 0 here. Not necessary, but just because we're talking about money, it helps. So here it says B is the initial or starting value of the function. Well, that's true. 330, that was our starting amount. That was initially what we had to pay. So when we put in x equals 0, and in our case, m equals 0, this is also called the y-intercept. And in this book, it's also going to be called the vertical intercept. Because again, we can call it the y-intercept because it is the vertical line, but here we've called y C of M. So if you see something that says vertical intercept, it is the same as what we would call the y-intercept. We have our M, which is our slope, is the constant rate of change of the function, which is the same as the slope, okay? So we have the rate of change is the same as the slope. And this form of a line is called slope-intercept form. It's called slope-intercept form because we have M is our slope and B is our intercept. So just to make it easy, it actually is called exactly what it looks like. Many people like to write linear functions in the form f of x equals b plus mx because it corresponds to the way we tend to speak. The output starts at b and increases at a rate of m. Remember, when we started our last example, or our first example, we started off saying, well, we have to pay this $3.30. And then it's going to change at a constant rate of $2.40. Okay, so either way, they mean the same exact thing. For this reason alone, we will use f of x equals b plus mx form for many of the examples, which is actually why I'm bringing it up. Many of the examples that you'll see in this book, the b will come first and the mx, or the intercept, will come first and the slope or the rate of change will come second. But you can even change it into whatever it is you would like to see. Let's talk about increasing and decreasing slopes. M is the constant rate of change of the function, which is also called the slope. It's a constant rate of change for every line. Whenever we talk about things that aren't lines, we may not have a constant rate of change, but for lines, we will always have a constant rate of change. So let's talk about each one individually. So let's do the first one. This says f of x, or our linear equation, is increasing if m, the slope, is greater than 0. How can we tell if the slope is greater than 0? We always read graphs from left to right. So this is increasing. because even though I can have an arrow at both ends, if I read from left to right, as x increases, y increases. Therefore, we have an increasing function, also a positive slope. Positive slope. M is greater than 0. Now, let's do negative slope. Well, a negative slope, if I read from left to right, it is decreasing. So notice as my function, as my x increases, my y is decreasing. This has a negative slope, and m is less than 0, which is what this says. And then I have one other possibility. If I have m is greater than 0 and m is less than 0, the last possibility is m equals 0. So if I have m equals 0, basically we have a function whose slope doesn't change. So it stays constantly at the same level of y. So I'm reading right here, if m equals 0, the rate of change, 0, and the function f of x equals b plus 0x, which equals b. And it's just a horizontal line passing through whatever the point is of my initial value. And it's neither increasing or decreasing. It's just staying constant. This function is increasing, this function is decreasing, and this function is constant. And here we have another example. So let's see what exactly we're going to look for. I'm going to highlight the important things. Marcus currently owns 200 songs in his iTunes collection. Every month he every month he adds 50. So every month he adds 15 new songs. And we want to write a formula for the number of songs. And we're calling the number of songs N in his iTunes collection as a function of the number of months, which we're calling M. Okay, so we can start by saying that the number of songs he has as a function of the number of months that we're counting is going to equal, and again, we're going to start with our starting value. Marcus currently owns 200 songs. So we can say this is 200. And then he's going to add, every month, he's going to add 15 songs. So in the first month, he's going to have 215 songs. The next month, he's going to have 15 more songs. So he would have 230. Basically, what we're doing is we're going to multiply 15 times the number of months that he is accumulating more songs. Okay. Now, the question, this is important because I haven't answered the question. And that's why I say always go back and read over. The question says, how many songs will he own in a year? So the question isn't what is the equation? The question is how many songs will he own? So what we do is we take our function n of m. That's equal to, we're starting with 200 and we're adding 15 songs every month. And in 1 year, we're going to have 12 months. So I'm going to multiply 15 times 12, which is going to give me 180. So this is going to equal 200 plus 180. How did I do that? Well, I said 15 times 10 is 150. 15 times 2 is 30. 150 plus 30 is 180. And that's why I don't always need a calculator. You know, if you have different strategies for doing certain things, now we have, this is my answer. How many songs will he own in a year? 380. Marcus will own these 380 songs. Okay. Now we're going to learn how to calculate the rate of change. What is another word for the rate of change? Slope. And that's exactly what the next sentence says. And if you remember, we have an equation for slope. It's given here as the slope is equal to the change in output divided by the change in input. This delta y over delta x means exactly that. The change in y over the change in x. Remember, our input is x, our output is y. And again, we have y2. Let me make this a little bigger. This says y2 minus y1 over x2 minus x1. So let's kind of break this down a little. If I were to put a graph, here, let's see. Let's put a graph right here. And let's say I have a line that looks like this. What I want to know is the difference in the y values. So this right here, if we call this x1 comma y1, and we call this point here x2 comma y2, it doesn't actually matter what I call them or what I name them, but I need to name them something different. So notice here, this value here would be y1, and this value here would be x1, because that is where, so if I go out to x1 and up to y1, I would get my point. This point here is y2, and this point here is x2. And if I were to want to find the slope, I really want to just find the distance between those two y values, and I'm going to divide it by the distance between these two x values, and that's going to give me my slope. Sometimes it's easier to remember it as the rise over the run, because the rise is going to be, the rise over the run. Because when we rise, we're talking about the y values. That's the vertical values. We run horizontal, we don't run vertically. So this is another way that might be easy to remember. And we really just want to know the distance between those values. And then here it says there's a note. In function notation, y1 could equal f of x1 and y2 can equal f of x2. So we could equivalently write that the slope is equal to f of x2 minus f of x1 over x2 minus x1. So the population of a city increased from 23,400 to 27,800 between these 2 years. And it said, find the rate of change of the population. So we're finding the change of the population over this time span. I think the easiest way is let's make a set of ordered pairs. Let's make this, the change in population, our vertical. And we're going to call these numbers our horizontal. And if I were to graph this, I would have, let's say we started 2000, 1, 2, 3, 4, 5, 6. So this would be 2001, 2, 3, 4, 2004, 2006. And this we'll call it T for time. Okay. And now vertically, we're going to have to use these big numbers. So I think what I'm going to do is start it here, and I'm going to call this 20,000. Because remember, we're going to actually have to go to 27,000. And then I can make 7 marks, 1, 2, 3, 4, 5, 6, 7. Actually, we're going to need 8 because this is going to be 21,000 and 22, 23. So this right here is 23,000. 24, 25, 26, 27. Hopefully I'm counting right. 27,000 and 28,000. Okay. Now, if I were to plot these points, I would say in 2002, I'm at 23,000 and 400. So let's say right here. And in 2006, I'm at 27,800. So probably somewhere around there. And we can see that my line is going up. So this is an increasing function. And that makes sense because right here it says the population of the city increased. So we should have a graph that's increasing. If I want to find the rate of change, I need my slope. So I'm going to take my ordered pairs. I have one pair that is in 2002. I have 23,400 people. And in 2006, I have 27,800 people. So how do I find my slope? I just take the two different values. We're going to call this x1, y1, x2, y2. And again, it doesn't matter which one you call which. And I'm going to say my Y2 minus my Y1 divided by my X2 minus X1. And this is going to be 4,400 divided by 4, which equals 1,100. So my slope is 1,100. And I can say slope is equal to 1,100. And I can say that my rate of change is 1,100 people per year. Because I have my population in the numerator and I have my year in the denominator. So on average, my city is increasing at a rate of 1,100 people every year. Okay. Let's talk about the next question. We have the pressure in pounds per square inch, PSI, on a diver depends upon their depth below the water surface. And we're going to call that D, and it's in feet. So P is pressure in PSI, and D is depth in feet. And we have, actually, we've already been given the equation. And it basically asks us to interpret what this means. So, what does it mean? It means that when I am at the surface, okay, so when I'm at the surface, that means my depth is 0. So my pressure, which is P, is equal to 14,696 PSI. That's my initial value before I start to dive. Okay? Then, as I descend below the surface, the pressure will increase by 0.434 PSI for every foot I go down. Okay, so basically this is what this equation says. It is constant. As I descend, my pressure will constantly increase by this 0.434 PSI. Okay, and that really is exactly what this says. Now here we're given a graph, And we want to actually write the equation for the graph. How would we do that? Well, it's not giving me variables. I can make them up myself. So let's make this x, and we can make this y, just to make it easy. So remember, my equation is going to be y equals mx plus b, or y equals b plus mx. Unless someone tells you what they want, it doesn't matter which way you put it in. And we can see here that my y-intercept, or my vertical intercept, is at 7. So I'm going to do it. I'll do this one. So we have y equal mx plus 7, because that's where I'm starting. And then there's a couple of different ways you can look at for the slope. But in my opinion, the easiest thing to do, especially if you're given a graph, is you find 2 points that the line actually cross that intersect. So for example, notice right here, that line goes exactly through one of my grid points. And before that, it's not. I would have to do estimating. But I know right there it goes through that grid. So I can say a couple of things. First thing I could say is I have 2 points. When x is 0, y is 7. And when x is 4, y is also 4. And I can use my slope formula, which says the change in y, so I'll call it y2 minus y1 over x2 minus x1. And I'll call this point 1 and this point 2. So my y2 is 4. My y1 is 7. My x2 is 4. And my x1 is 0. This becomes -3 over 4. So my slope for this function is -3/4, which actually seems right because it's negative, and look, this function is decreasing. Another way I can do it is I can actually count the boxes. If I start at 7, I'm going down. When I go down, I'm going negative, right? 1, 2, 3. So I'm going down 3. I'm going to say -3. And then I'm going over 1, 2, 3, 4. And I'm going to the right, which means I'm going in the positive direction. Either way, I get the same answer. Okay? So it says write an equation for the linear function, graph to the right. I know my m. I know my b. My b was 7. So I can say y is equal to -3/4 times x plus 7. And that is the equation of that line. If I'm given f of x is a linear function where f of 3 equals -2 and f of 8 equals 1, and it tells me I want to find an equation for this function, same thing. F of x is equal to y. For the first equation, I'm given f of 3 is equal to -2. F of 3 is equal to -2. For my second equation, I'm being told f of 8 is equal to 1. So even though it's in a different form, I have an ordered pair. Remember, all these purple are x values. So I have 3, comma, and 8, comma, and all these numbers here are my y values. So I have the y that goes with 3 is -2. The y that goes with 8 is 1. I have my ordered pairs. I can now find my slope. My slope is equal to y2 minus y1 over x2 minus x1. And it doesn't matter, again, which one you pick. I'm just going to say the first one is 1 and the second one is 2. Now, that means that y2 is right here, 1 minus y1 minus 2, divided by x2, which is 8, minus x1, which is 3. This equals 1 minus minus 2 is the same as 1 plus 2. So this is 3 over 8 minus 3, 5. So I now know the slope of my line is 3/5, which is the same as the rate of change. So let's start. We have y equals mx plus b. I know m. I do not know b. How can I find b? Well, I do have 2 ordered pairs, right? I have this ordered pair and this ordered pair. And all I really need to do is plug one of those ordered pairs in for x and y and solve for b. So y equals 1. I'm going to use the second one. So y equals 1. That equals 3/5 times x. X is 8 plus b. 1 equals, I'm going to multiply this together, and really 8 is the same as 8 over 1, so 3 times 8 is 24, divided by 5, plus b. Now I'm going to subtract, here, let's rewrite this here. 1 equals 24 over 5 plus b. I'm going to subtract 24 over 5 from both sides, and I get 1 minus 24 over 5. This is 0 equals b. I'm going to take 1. Whenever I add or subtract fractions, I have to have a common denominator. So I have this 5. What I'm going to do is I'm going to turn 1 into 5 over 5. I'm going to subtract 24 over 5, and that's going to equal 5 minus 24 divided by 5, which is equal to negative 19 over 5, and that is my value for b. Now I have everything I need to write my equation. So I'm looking right here, and I have, or actually right here, I have y is equal to 3/5 x, because I already found m, and my b is negative, so it's minus 19 over 5. And that is the equation that represents these values, as long as I know it's linear. As an alternative to the approach used above or in previous slides, if we want to find the initial value v, we can use the point slope form of a line instead. So we had to go through kind of a little bit of work to find b, but there's another thing we could do. And we could use this point slope equation. And I think that the best way for me to explain how to remember it, let's see if this helps. Remember, our slope is always going to be y2 minus y1 over x2 minus x1. If I multiply both sides by x2 minus x1, I end up with this cancels with this. So I end up with x2 minus x1 times m is equal to y2 minus y1. But we're only really given 1 point and the slope. And here I have 2 points. So instead of saying 2 points, this x can be whatever, and this y can be whatever. And I have now basically matched point slope. This is my point slope equation. And if you forget it, this is a good way to try to remember it. This is going to come in very handy in this class because often we have 1 point, we can find the slope, and why bother trying to find the y-intercept if we don't really need it? So let's look at this example. Working as an insurance salesperson, Ilya earns a base salary and a commission on each new policy. So Ilya's weekly income, I, depends on the number of new policies, N, he sells during this week. Last week, he sold 3 new policies and earned $760 for the week. The week before, he sold 5 policies and earned $920. And basically, it's asking us to find an equation for this I of n and interpret the meaning of the components. Again, I have 2 equations, right? One equation says that Ilya sold 3 policies. So let's call this policies, and we'll call this income. So when he sold 3 policies, he made $760. When he sold 5 policies, he earned $920. And I want to find an equation for I of P. So that means that this is not P, this is N. We want to find an equation for I of N, so I have to name the number of policies N, and I would be the amount he earned. And let's see, does it ask me? Okay, so it wants me to find an equation. Well, I have 2 points. I have 3,760, and I have 5,920. And again, I can call this 1, I can call this 2, and I can find my slope. My slope is equal to y2 minus y1 divided by x2 which is 5, minus x1. This gives me not 920 minus 760 is 160 divided by 2, which means my slope here is equal to, it's a little smaller. This is equal to 80. Okay, so I found the slope or the rate of change of this function. Now, how am I going to use that? Well, I could go and find my y-intercept, but I don't really need to. I'm going to use this point slope equation because I have a point. It doesn't really matter which one you use. I'll use the first one because it doesn't matter. Okay, so I'm going to use the first one for my point. And I know my slope. My slope is equal to 80. I just plug it into my formula. And I have y minus my y1. I'm using the first one, so I'm saying 760 is equal to m, which is 80 times x minus 3. And look at that. I didn't have to do any kind of finding my y-intercept. If I have a point and I have the slope, I can put it into point slope form. It says, find an equation and interpret the meaning of the components of the equation. So m is my slope, which is my rate of change. And what does that mean? For every policy that Ilya sells, so my interpretation would be, for every policy Ilya sells, he makes $80. Okay, that's basically what this says. For every policy that he sells, he makes $80. If that's true, then 3 times 80 would be 240, but he's making 760. 5 times 8 is 400, but he's making 920. That's because he's obviously getting a base salary, and then he's getting a commission on every policy over that. Okay. Keeping track of units can help us interpret this quantity. We can now write the equation using the point slope form of the line, which is what we did here. I'll just copy it here. We have y minus, this is, when they say keep track of units, this is $760. That equals $80 times, and instead of x here, what we're going to do is use, actually, this should not be y. This should be I of n. That's the income that he makes for some amount of policies. And that's going to be $80 times n minus 3, where n is the number of policies sold. Okay. If we wanted this equation, this function in the slope-intercept form, we can rewrite it. So I can say I of n minus 760. I'm going to leave off the units for a minute. I'm going to distribute that 80. I get 80n minus 80 times 3 is 240. I'm going to add 760 to both sides. And I get 80N plus 520 is equal to I of N. Now, this is in slope-intercept form. This form allows us to see the starting value for the function. Now I can see that Ilya has a base salary of $520 per week. He then earns an extra $80 for every policy that he sells. And that really is everything that you could possibly need to know about lines. Now, it just wants me to graph this. It's very easy to graph something like this because we have our vertical intercept, also called our y-intercept, and we know our slope. So I'm going to start with my vertical intercept. That is 5. So I come here when x is 0, y is 5. 1, 2, 3, 4, 5. I have this point right here. And then my slope is minus 2/3, which means, so minus 2/3 is really the same as minus 2/3, or I can say 2/-3. All of those are equal. So if I go to this one, that means, remember it's rise over run, so I'm going down 2. So I'm going down 2 and to the right 3. 1, 2, 3. And this point is what I would get if I went down 2 and to the right 3. Also, I can say it's the same as that, which means I'm going to go up 2 and to the left 3. And I have that point. If I take my ruler, these 3 points should all lie on the same line. And they do. So let's draw a line through all of them. And let me make this a little thicker. So here's my line. Okay. So I've now graphed this function, and that is exactly what it looks like. Notice we have a negative slope, which is good because it's going down if I read it from left to right. And we have our y-intercept, and that's really all that you need. Now we're going to match equations. Okay, so match each one of these equations with one of the lines in the graph below. First, let's pick a line. I'm just going to pick this one right here. I can see that my vertical intercept is 3. I have 3. I also can tell this is positive. My slope here is positive. So let's pick 2 points. Okay, I'm going to pick the intercept because I definitely see where the intercept is. And this point right here, because I can also see that that crosses right through that grid. So if I were to do my rise over run, I'm going up 1 and to the right 2. That's my slope. So this is the equation of that red line is 1/2 x plus 3. So this line right here is j of x. Okay? So 1 down. And I'm going to get rid of everything because they're all going to interfere with each other if I don't. Well, one that's really easy to see is this one right here, because if you look closely, that looks like the only line that's decreasing. So it's the only line that has a negative slope. My y-intercept is 3. So h of x is the only one with a negative slope. And there's my y-intercept of 3. So let's call this h of x. Okay, it's going pretty easy, right? Now, I only have one line that's going through -3. That's my intercept. So that means, again, it has to be g of x because that's the only one with a negative intercept. So we're going to have to call this g of x. And that takes care of that line. And obviously we have one more line left. And that line, hopefully, is f of x. So it does have a positive slope. It goes through +3. And I'll pick these points down here just to be different. Notice it's going up 2 over what? So my slope is 2, which means this line is f of x. And I've now accounted for every line. So I think that's pretty simple. Horizontal intercepts. Those are also called x-intercepts. Here it says, the horizontal intercept, also known as the x-intercept. It's also known as my solutions, and we can also call them zeros. Of the function is where the graph crosses the horizontal axis. So if I were to look at a graph, everywhere that I cross the horizontal axis, let's talk about, let's say, what is this point? An ordered pair. That's x equals 1, y equals 0, right? This point here, x equals 3, y equals 0. This point here, x equals -2, y equals 0. What do I notice? Y has to equal 0 for the line to cross the x-axis. So all I really have to do to find my horizontal intercept or my x-intercept or my solutions or my zeros is I set f of x or y equal to 0. So I would have 0 is equal to -3 plus 1/2 x. Add 3 to both sides. I get 3 equals 1/2 x. Now I'm going to multiply both sides by 2. That's going to cancel this 2 with this 2. And I get x equals 6. X equals 6 is my horizontal intercept for this function. It's also my solution. It's also my 0. Okay, my ordered pair would be 6, comma, And then I would plug in 6, but do I have to? Not really. I already know my y value is going to be 0. So that is my ordered pair for my horizontal intercept. Two lines will intersect always if they're not parallel. The only time two lines will not intersect is if they're parallel, if they run right next to each other. Think about railroad tracks. Railroad tracks are parallel. Hopefully, they never intersect. If they do, what would the wheels of the train run on, right? They always have to stay the same distance apart so that the train doesn't go off the tracks. So economists tell us that a free market, the price for an item, is related to the quantity that the producers will supply and the quantity that the consumers will demand. Increases in price will decrease demand, while supply tends to increase with prices. So let's just talk about what that means for a second. The lower the price, the more people will buy that thing. Like if I have a television set that costs $1,000, less people will buy that television set. If all of a sudden I sell that television set for $100, a lot of people will want to buy that television set, right? That would be called the demand function, okay? And then the supply function, well, I'm only going to supply enough that people are going to buy it. And I have to make sure that supply and demand have some point of intersection, and that point of intersection, so example, the supply in thousands of items for custom phone cases can be modeled by the equation S of P equals 0.5 plus 1.5 P. So this right here is S of P. I can tell because my slope is positive, it's going up. The demand can be written D of P equals 8.7 minus 0.7 P. This is D of P, where P is in dollars. Find the equilibrium price and quantity, the intersection of supply and demand curves. Right here is where they intersect. That point of intersection is called the equilibrium price. Okay, and how will I find it? Well, we're going to have to estimate it a little bit on this. If we look at the graph, we would have to estimate it. But we do have the actual functions. So since we can say that if we say S of P and D of P are Y, I have Y equals 0.5 plus 1.2 P. And also I have Y equals 8.7 minus 0.7 P. And because I want these Y values to be equal, I can just set each one of these equal to the other. I can say 0.5 plus 1.2 P is equal to 8.7 minus 0.7 P. And then I can just solve for P. So let's subtract 0.5 from both sides. And let's do at the same time, we can just add 0.7 P to both sides. Now, when I add these two equations together, 0.5 minus 0.5 is 0, gone. 1.2p plus 0.7p is 1.9p is equal to, so we have 8.7 minus 0.5, we get 8.2, and negative 0.7p plus 0.7p is 0, That goes away. I can now divide both sides by 1.9. And I end up with P equals 4.3. And what does P represent? P is representing the price in dollars. So I get P equals 3.15789, but that's not in dollars. I need to round that off to dollars and cents. So let me say the optimal price, or the price of equilibrium, would be 4.32, or $4.32, because I'm going to round just to 2 decimal places. That would be my optimal price. And let's see, the supply, how much supply do I need? I can just plug this in to my equation. So my supply equation is 0.5 plus 1.2 times P, which is 4.32. Let's see what that equals. This is 5.684. If I multiply this by 1,000, I'm going to get that I need to supply 5,684 phone cases at a price of $4.32. So that is basically what I need to do to find my point of equilibrium. And that concludes linear functions. Thank you for watching.